right. All right. Hello, Java community. Good evening. My name is Rodrigo Graciano, and in the name of the NY Java SIG, I would like to welcome you. We're very happy to have you with us today. We're very excited for the event today. One of the speakers, Frank Greco, was the creator of the NY Java SIG 25 years ago. And he'll be, as I said, one of the speakers tonight. Machine learning is a very hot topic, and Java needs to be part of this race. We cannot imagine the machine learning world without Java. I would like to ask you to follow NY Java SIG here on Twitter, subscribe to our YouTube channel. We are very active on Twitter. Okay, so if you want to interact with our members, with our group, use the Twitter. We announce our events on Twitter. Have any questions about Java you want to discuss, you have ideas, you want to talk at the group, please, Twitter is the place to go, right? Before we start, I would like to ask you to use the chat. So here on YouTube, on the side, you have the chat. Participate, ask questions. We want to participate on this event. Before we start, so I think we did last on our last event, and we want to do this again. It's trivia time, right? So we have some questions about Java to test your Java knowledge. Our team will be posting on the YouTube the links to the trivia, and we have two questions today. The first one, let me.
Well, before that, we have two really easy questions, which I hope everyone knows. The first one, which I just posted, is this your first meeting? So if this is your first meeting, you answer yes. If it's not your first meeting, you answer no. This should get everybody used to using Menti, and it's a question that you all better know the answer to. Then we're going to ask a second easy question, and then we're going to jump to the true trivia questions that Ricardo mentioned. Sorry, that Rodrigo mentioned. Okay, so let's see how we're doing on questions about whether it's people's first meeting.
Just 1 second, having some issues to share the screen.
Okay, so far we're having a lot of people who have attended meetings before. Very cool. I'm going to give it another couple of seconds, and then we'll go on to our next question. Okay. Our second question is, what version of Java are you using? We always ask this at physical meetings. It's a good way of knowing whether people are on the latest versions of Java or they're on old versions. Our choices in the Menti survey that I posted range from Java 5. If you're using Java 5 in production, I feel bad for you. In fact, there's even a choice if you're using Java 1.4 or earlier. Please, 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 please don't let that be true for anybody. But we also have a choice for people who are on Java 11 LTS or 12 or 13 or even 14. And it's nice to know that we have those options that somebody might be on a later version. So let's look at the results and see what people are posting.
Just 1 second.
It should be interesting to see whether people are on later versions than they used to be, because the last time we did this, everyone's versions were really, really, really old. So survey says that people are a lot faster to answer whether it was their first meeting than whether they are on the current version of Java. Give it another 10 seconds or so and see if people can figure out what version of Java they're using in production, because this seems like something that people would know. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Blast off. All right. So we didn't get that many results there, but that's okay. You can still vote, and we shall accumulate your results. Our next question is the first of the two actual Java trivia questions. We've got some code on the screen. It's about creating a set. We have an array. It's got 6 strings in it, all the words in the world, because actually using all the words in the world would use up lots of space. So we're only using a little space. And then we put those in a list, and we put that in a hash set, and then we print out the hash set. And we want to know what the results are. Please put this in the Menti. I see a lot of people posted that they're using Java 8 and 14 in the chat. We were hoping people would use the Menti, but that's okay because we're going to do it for the survey. So for the survey link that I just posted, the one that ends with J6 as the link and 82 as the mobile code, let's go to that and see if people know their Java and know what it prints out. Our first person to answer did it correctly. Yay. Let's see if anyone wants to challenge them on a different answer. But this question is not meant to be tricky. So if you want to use Menti, this is your chance to get the right answer. Okay. And we're going to do our next trivia question. Our next trivia question, can you advance the slide, Rodrigo?
I have the answer here. Should I be?
Oh, we were doing it. But let's go to the next question. I didn't realize we had the slides with answers.
Okay. Oops. There we go.
All right, so we've got our next question. We've got the same array, all the words in the world. Again, too much content to actually have all the world. And then we use set of to put them in a set because creating a list, and that's just silly. We don't need a middleman here. And we're running the same code. So we're going to go to the Menti and see what the output of this is. Again, please post it in the Menti and not the chat so that we can all get to participate in this fun game of how well do you know your Java. And we already have an answer, all the words in world. That means that people know how sets work because they don't have the word the in there. Let's see if there are any other answers to challenge that one. Maybe people have a different opinion on what gets output here. Jeopardy's copyright if you play it for real, but not if you hum it. Okay, so we have a couple people who are saying it's all the words in the world. Unfortunately, I gotcha. Can you reveal the answer, Rodrigo? The answer is the legal argument exception. If you read the Java doc for set.of, it says that the var arg signature, which is the one that we're calling here, requires the values to be unique, whereas the one on the previous screen where we had a list actually filters out the unique ones for you. I looked at this Java doc because I wrote code that looked like this and was surprised by the output. But now you've learned it as Java SIG, so you won't be surprised by the output too. That concludes today's trivia. We look forward to seeing you next time we have a meeting to see some more surprising Java language behavior. Rodrigo?
All right. Thank you, Jean. That was very good. Thank you very much. So now it's time for our main event. JSR 381 is a Java-friendly API for machine learning. We'll talk about the goals of the JSR 381, the API, and the internal architecture. So for that, I would like to invite the speakers. So we're going to have 3 speakers tonight. Zoran Severak, he's a Java champion, one of the spec leads of the JSR 381. Kevin Berenson, senior software engineer, Open Value, a JSR 381 contributor. And Frank Greco, NY Java SIG chair, Java champion, cloud machine learning consultant, and one of the JSR 381 spec lead. Frank?
Thank you, Rodrigo. Can everybody see my screen?
Yes.
Good, excellent. So thank you everybody for joining us in the New York Java SIG. Today we're going to talk about JSR 381, which is visual recognition for Java, as affectionately called VisRec. And what we'll do is that we'll talk, Zoran and I and Kevin will talk about, oops, sorry about that. We'll talk about the JSR 381. And I'll talk about a little bit of history on why we're doing 381, JSR 381. Zoran will dive into the API and some of the architecture. I think you'll find the architecture discussion very, very interesting. And then finally, Kevin will show his really cool Star Wars demo, which is really awesome, that uses JSR 381. So I don't want to duplicate this part of the talk that I gave about 4 or 5 months ago on introduction to ML for developers. If you're a Java SIG person, you saw me. This is face to face. I remember those types of meetings. where we talked about the importance of ML. So I'm not gonna duplicate that. There's a link down there. You can see my presentation, but just a quick step back to make sure we're on the same path. In my opinion, and I have many opinion of many, that machine learning, this we're talking about a huge step for computing, and a lot of people, a lot of experts in ML, like Andrew Ng, who's one of the godfathers of ML. He's calling this like, this is like electricity. This is a big invention. And it's whether it's like electricity or the printing press or like the computer itself. As I learned more about it, this is like going about 3 years ago, the more I learned about it, the more fascinated I become, because there were so many various threads related to ML. It's not just about, we're going to talk about visual recognition, but it's not just about recognizing clouds or cats and dogs or bad tires or things like that. But ML has impact not just at the application level. It has implications at the data structure level. It has implications for operating systems. It has implications for hardware. We're actually questioning why we have the CPU and memory separate. They should be together. We're talking about new types of hardware. It's just mind-boggling, the applications. And not only at the computing level, if you go way up the stack, past the application, past your manager, and we're talking about like political impacts, geopolitical impacts, country impacts, ethical impacts. So this is a huge field. It goes beyond just a programming language. This is a monumental change for the entire planet. So I urge you, as Java developers, as fellow Java developers, and as technologists, learn about ML. Really learn about ML. It's critically important. It's going to affect the rest of your life. And just for some nomenclature, because we've heard some of these terms in the popular press. Certainly, we've heard about AI, and we've heard about AI going back to the 50s, right, mid 50s, when the term came up, and even before the 50s, in the 1940s, pattern recognition, cybernetics. You may have heard the term cybernetics. This we're talking about the 40s. There's a lot of things that I sometimes say there's nothing new in computer science. It just gets tweaked over time. So AI is pretty old. A subclass, since we're all Java developers here, a subclass of AI is machine learning, where the machine is learning and looking for patterns, right? That's what machine learning is in a nutshell. And then we have a subclass of machine learning is called deep learning. And again, it's a subclass of ML. So it's a type of ML that uses new types of algorithms and techniques like neural networks and cloud computing to really take machine learning to the next level. But in the popular press, you'll probably hear the term machine learning more than deep learning, even though deep learning is the more correct term. But you'll certainly hear machine learning. It's been, not just the journals that we read, but even in the popular press. So let's stick with machine learning. So again, real quickly, and this is why I got fascinated by machine learning. It's a different way of doing programming. The way we've been doing programming for the past 50, 60 years is that we come up with an algorithm, right? When you solve a problem at work, your manager says, we have this problem, we have to do this. You come up with a problem and you think, how would I solve it if I didn't have a machine? So it's like allocate, okay, there's services over here, and this is how I do the service, and there's a bunch of if statements, there's a database. So you basically are thinking of solving the problem like a human, except you're going to give it to a machine who's going to do it better, right? It's going to do it faster, more accurate, blah, 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 right? But you're solving the problem as if you're going to solve it. It's a human perspective of a problem. Machine learning is different. So if you look at it like learning a foreign language, there's two ways of learning a foreign language. You could spend all your time learning about the rules, right? About sentences and nouns and prepositional phrases, and you just learn the rules and you have the structure, right? You have the algorithm of language. Or you can go to have a person that you talk to and you learn by patterns and say, is this right? That's right. That's right. What you're saying is right. Oh, what you're saying is not quite right. It's wrong. So let me correct you. So you're building up by patterns. So machine learning is like the right-hand side here, is by following patterns. And what we've been doing programming by doing rules is really the left-hand side. It's the older way of doing programming. So machine learning is really a different way of solving problems. So what's the core of machine learning? So it's about recognizing patterns in data, and, having the machine look at patterns in huge amounts of data, and then making inferences or predictions against that data. That is the core of machine learning. It's just like, if somebody asks you, what's cloud computing? You're like, okay, what is cloud computing? You think of a million things. It's a programmable data, a programmable data center. Machine learning, here's a simple one sentence: recognize patterns in data and then make predictions against that data. And this is what you give to your boss. This is what you tell your boss what machine learning is. It's that, okay, I'm going to recognize patterns, but then I'm going to give you likely scenarios, what's going to happen based upon those patterns. And then we're going to take steps to either make money or save money, and to maximize ethical, and the key word there is ethical, business benefit based on those predictions. Just like if you see people crossing the highway, people are going to get hit by a car, and nine people in a row get hit by a car, and you're the 10th person. What do you think is going to happen to you? It's a pattern, right? So you say, I'm not crossing the street. I'm not crossing the highway. So you're recognizing patterns and you're predicting the future based upon the past. And then you're taking advantage of it. Businesses are taking advantage of that, whether it's, to be more profitable, save money, to help people and employees, et cetera, is to help companies. So this is a good definition to take to your manager. But what's the problem? Why are we here talking about JSR 381? So we all know that, okay, I want to learn about machine learning, and I'm a Java programmer. It's like, well, you'll have to learn Python. So everywhere you look, it was Python. This goes back, 3 years ago, and I think both Zoran and I had the same feeling as we're in Java conferences like at Code One and Java One talking about machine learning, and we're talking about Java. But so he said, no, you have to learn Python. So what about us Java developers? And what about us Java developers? There's 12 million of us, right? There's 12 million Java developers. How does the Java community get involved with machine learning? So again, this is going back 3 years ago. I started thinking about what JavaScript meant to the web. Here was the web. It was a phenomenal innovation. It's something that was big to mankind, right? And we have all these people on the planet with all kinds of creativity skills. And you were telling them, you only have one language to express yourself. Personally, nothing against JavaScript, at least not publicly. But it's only one way to express yourself is not a good thing. So I didn't want that to happen. There's nothing wrong with Python. Python is a very good language. There just should be other languages. There should be C, C++, all kinds of Rust, whatever the language is. There should be other ways of expressing yourself creatively. And being a Java developer and being a Java champion, why can't we have 12 million developers do ML? And the last bullet, Zoran will go into more detail on specifically why aren't they Java friendly. So again, like I ran a conference. This goes back to 3 years ago, so just 2 years ago. I ran a conference on machine learning because that's the best way to learn about it, is right. You either teach or you run conferences on topics. So I ran it, and it happened. Luckily, it was in a beautiful city in Rome, and this is when we had in-person conferences. You may remember those. And it was a 2-day conference, and the first day we had all these really great speakers, and we all went to a great speaker dinner. It was a really nice speaker dinner, except one of the speakers couldn't make it. He was running a marathon, and he couldn't make the first day. So he made it the second day. but we had a speaker dinner the first night, and all the other speakers went off and they were, having a good time someplace else. But I wanted to treat this speaker. So like, let's go to dinner. And we went to this restaurant across the street from the conference. It was called El Gran Sasso, small bistro. And we had this phenomenal conversation about Java and ML. So Humphrey Schell, who was one of our speakers at that conference, he was a longtime Java developer like myself. So we were, going back many, many years. He had to do, study, he wanted to study ML and get his PhD. And he said, I had to learn Python. I had to do all this stuff in Python, Python this, Python that. And he said it was a pain in the neck to deploy it. So we had this long discussion over a couple of nice bottles of wine. It was a really good discussion. And we talked about all the things that Java needed. So if you go to medium.com, you search for this article, and I think I put the little link down the bottom, you'll see all the things that we thought that Java needed. And I said, yeah, we need to promote Java for machine learning, but we didn't see anybody doing it. So this is a couple of years ago, and at this point, I'm talking to Zoran at Code One and Java One, and we're both members of the Null Pointers, which is a musical band of Java champions. And little did we realize we had a common interest in promoting Java for machine learning. And we had talked to all these companies, like, are you interested in Java and machine learning? All these companies said yes. All of them said yes. We would love to have a Java API for machine learning, but everybody was doing it their own way and their own APIs. So we decided how do we get Java to play a bigger role? All right, so we're not going to boil the ocean. That's something that your manager will tell you, right? Do something that's deliverable. So we said, well, why not visual recognition? Because that's fun, right? And that'll be fun for developers to play around with. So we decided, the three of us decided, like, let's do JSR 381. We got some interesting friends to help us. We had Frank Liu from Amazon. We had Nikita from GridGain, Jim Weaver from IBM, another fellow Null Pointer. So we had Oracle, Google, a lot of people are interested in helping out. And we recently have Nishant from the Mumbai Jug, who's been really, really helpful in helping us debug a lot of things in our first release. And recently we had an article with the Amazon gentleman on using their DJL library with our API, which is, if you go to InfoQ and just search for that title, it's a really cool demo. So at this point, I think Zoran's going to dive into the architecture and the API and how to use it. So let me turn over to Zoran, if you can share your screen.
It's disabled. Screen sharing is disabled, Frank.
Okay, hold on.
Please allow me.
Give me 1 second. Try it now, Zoran.
Okay, that's it. Okay, can you see it all?
Yes.
Okay, hello everybody. Frank gave a pretty good introduction for what about is to come, like a general overview and the motivation for the work that we are doing. And some of the things that he mentioned is that there are different Java machine libraries out there that people are using that are relatively popular. But the thing is, they all have different APIs. They don't have anything in common, despite the fact that many of them are doing the same thing on a different way. So one of the challenges when Java developer decides to get into machine learning is how to pick a machine learning library, how to pick the algorithm. And the problem is that all these libraries are not compatible and don't play well with each other, most of them. And sometimes you feel like, every library is reinventing the wheel, re-implementing the same things again. And it is very difficult to change them once you start working with some of them. to change the application. And then also, if every library requires that you relearn it again and see how they are doing things with their API. To add to that, some of them have a very are not what a Java developer would expect from the API. They have a C flavor, or they have more Python flavor, so you don't feel like you're coding in Java, and it makes it difficult to learn, especially if you're not an expert in machine learning or things like image processing. So in order to try to solve that problem, we started JSR 381, and our primary goal is to enable Java developers to use machine learning using what they already know, using primarily their Java development skills. So we want to allow them to use machine learning through friendly Java API, and at the same time, they don't have to be experts in visual recognition or machine learning. So one thing to add to what Frank said, why we choose the visual recognition as an interesting domain, because that is one of the domains which is most actively being developed, and state-of-the-art algorithms and new innovations are happening in that domain. So it is a very good domain to start with. Another goal is to create an API that can be easily implemented with existing libraries. So we don't want to ignore the existing work and start all over again and create another library which nobody is using. But we were trying to create API that maybe some of the existing ML libraries will adopt and easily implement as an add-on. So it will make it easily to combine different algorithms, different libraries, to test them, compare them with each other, and reuse components from each other. And at the end, what we're hoping to get is to get a reusable design that can be applied to another domains, not just visual recognition. So in some of the next slides, you'll see the entire architecture. So the same principle that we used here to design like a generic abstract machine learning layer and specialize it for visual recognition can be applied in other domains like finance or you know, some areas of computer performance or anything else. So for the start, our approach was, as Frank said, don't boil the ocean. So let's focus on a few tasks, simple tasks that are typical and commonly used. I would say most commonly used for practical applied machine learning that's out there. So these tasks are so-called fall into what we call supervised learning, and these are classification and regression tasks. So it is very easy to understand what classification is from its name, is to assigning objects described by data or even images to a set to one of the predefined category. Then regression task is to model a relationship between values in order to be able to guess, to predict some value. And as the most complex task, there is the object detection, which, as you can see, can identify individual objects on the image. And it is interesting to note that these type of algorithms are actually combining classification and regression algorithms. They're using regression. They're using convolutional neural networks, which are using regression to find the position of the object, and then they are classifying that object. So it is an interesting combination, and that is what these modern machine learning algorithms as deep learning and convolutional networks brings to object detection. So this is the architecture of the JSR, and as you can see, one of the first ideas were to provide a connection to different machine learning engines. So we have the same public API that the user application is using. This is the public API. And we have this stack here with the visual recognition layer and generic machine learning layer. And different machine learning engines can be plugged into that stack. The way we have solved that is using the Java service provider infrastructure. So we have service provider interface for this generic machine learning tasks. So this generic machine learning layer contains classes which represent those three machine learning tasks that we mentioned in previous slides. That is classification, regression, and object detection. Classification also includes image classification. And each machine learning engine, in order to be to provide the algorithms for the JSR 381, has to implement this service provider interface, so service provider implementation. So we'll talk about later about available implementations. For now, we have two implementations. We have a reference implementation provided by DeepNets and another implementation by DJL from Amazon. So this entire concept is not just theoretical. We have tried it and we are still evolving it, but for now, it turned out that it works very well. And thanks to Kevin for his great work on this service provider infrastructure. So on top of this generic machine learning layer, we have visual recognition specific tasks. So we have classifiers here in generic layer, and we have image classifier in visual recognition layer. One of the problems that this API solves is that it allows users to use different machine learning algorithms provided by different engines using different types of images. Because maybe some of you are not aware of that, imaging is really complex in Java. There is buffered image in Java Standard Edition, of course, but then on Android, you don't have that class. You have a bitmap, I think. So because it is left out, it's in AVT package. And then for different types of images and different resolutions, there are many different imaging libraries. And in general, when you create algorithm, you want it to be able to use different type of images, not just a single one. And again, some libraries have been implementing their own type of images for their own good reasons. And we just decided to try to cover all that scenarios and provided a very convenient abstraction and image factory, so different type of images can be plugged in these engines. Because sometimes you want to classify images from Facebook. On the other hand, you want to classify medical images, which have different resolutions, different types of images, or you want to classify astrological images. So at the end, user should be able to use the same API, and the entire stack here should be hidden. It's all happening under the hood, and it should be very easy to plug different machine learning engines. We hope to get more implementations, and actually, I think, Frank, we can say it also now. Recently, GridGain has joined us, and they will provide expertise for building distributed machine learning. And we also started collaboration with many other machine learning related projects, and they all see these problems that we are talking about. And of course, somebody will make more adjustments, somebody will create less, but we are trying to figure out the best way, what is the minimum set of features and specification that we can all agree about, and try to push that as a standard, as a community. So here are the things that some of the classes that I have mentioned. how it looks in the code. So we have a generic machine learning layer. The most important classes here is data set, of course. That's how you store data. And if you take a look at existing libraries, every library has its own class for data set. So like, before we had the collections API, everybody were implementing their own collection. So now it is the same situation with data sets. One common interface for all data sets because they are all doing the same things, more or less. Then, as I said, these tasks that we are going to cover at first, these classic classification tasks and regression tasks, we have classifier interface. And as you can see, this thing that we introduced here is using these generics parameters, which are available in some other machine learning libraries. And we think it is very good practice because when you're classifying something, you feed something as input to classifier, and you're getting, as a result, a class of those input items. So input items can vary for different applications, and also the results can be strings, can be enums, can be different classes. So the way it is being done in some engines is that you're just feeding arrays, that is commonly used because that is data structure which is used a lot in Python and R, and Python developers are very used to that. But when you give array with a bunch of features to Java developer, he will expect more to have an object or something more high level. So that is the reason we try to cover these situations with these generics. So when you create classifier, you say what you put is input, what is the input type of objects to a classifier, and what will be the result. So as you can see here, in visual recognition layer, we have image classifier, which should, by the way, extend classifier and interface. And it is a classifier that takes images as inputs. So very, very simple concept. And for any other type of objects, you can just say, I'm classifying objects of this type, and extend this classifier interface. And then in order to make it easier and provide even more logic and utilities and plumbing for image classification, we create this abstract image classifier, which implements image classifier, that is the interface. And at the same time, you can specify the type of machine learning algorithm it is using. That is this generic parameter model class. So this is how we are creating an abstraction that will allow users to specify different type of images and what kind of different implementations of machine learning models. And this is the specification level still. And on the implementation level, we have image classifier network. So this is neural network which classifies images, and it extends from abstract image classifier. So as you can see, it is a classifier. It performs classification, and it performs image classification. And here we specify that it takes as input buffered images, and using convolutional neural networks from DeepNet's engine as a machine learning model. So I think when Java developer sees this, he knows just from the name what the algorithm is doing. It's performing classification, what kind of machine learning model it is using under the hood to get the idea what he can achieve, and what it accepts as input. So in this time, a buffered image. Of course, it will be very easily to provide different types of images and different types of machine learning model and use the same code. Now, following this principle for non-imaging domains, for example, if we do want to do regression, we still have a regressor, which also specifies input and expected output. And we here have the basic machine learning or statistical algorithm, linear regression. We have simple linear regression, which have this generic parameter, what kind of model it is going to use. And we have this simple linear regression network, which is specifying feed-forward network as a model. So this is the main idea. I don't want to bother you with much more details, but I think you get the idea. One of the problems that we find out about while talking to Java developers is how to pick a machine learning algorithm. If you're not experienced and you don't know a dozen of them and you see a library with a lot of them, how do you know which one to use? And if all of them take arrays as input, then you can pick any of them. It is very easy to pick a wrong one and difficult to get going with this. So I think this API will make it more clear what algorithm does, what to expect as output, and how to use it. So Kevin will go in more details with the image classification, but this is the general idea. In order to classify image, you have to build a model using a builder. Okay, so we Java developers, you know what a builder is, and we have this image classifier interface, right, which is classifying buffered images. That's like plain reading, right, like in plain English, and creating a model using builder. Now here's the tricky part, which you know, but you can look at the Java doc and see what all of these parameters represent. Some of them might not be so easy at first and require a little experimentation, but we hope to provide that in the next phase of development of these kind of standards will include development of tools which will help with setting these parameters. So you invoke the build method, and after that, if everything goes well, you get a classifier and you just invoke classify method with image that you get from some buffered image, and you get results, possible classes with a probability that the image belongs to one of those classes. So these are the two steps. And on this link here, I guess that slides will be available. You have a full example on the GitHub for classifying handwritten digits, which is like a hello world for image classification. Now, in a more, if you want to classify data or objects, there is also a type of classifier which inherits like a classifier interface that is a multi-class classifier. As you can see, it takes an array of floats, right? Some numbers, and it classifies them to some string, right? And this is also one of the hello world machine learning problems, which is classifying iris flowers. You have 3 types of flowers, and you have like 4 input features. And it is creating, the classifier is being created using feed-forward neural network. But as you can see, that information is hidden with the API. So when you are using this API, and that I must say also thanks to Kevin, to his good design, you don't have import from the underlying implementation. You're just using the API. And that's the beauty of it. So you don't have any dependencies to an underlying engine, and you can easily replace it, which is really important if you want to keep updated with latest development in machine learning. So you don't have to rewrite your code if you have to maintain it. It is very easy to keep the step with innovation. And in this yellow rectangle, you can see how the classifier is being used in a similar way. So you just invoke classify method and provide input, and you get the results, which is class names and corresponding probabilities. Now, what we are working on in the next version of the API, it's still not included in this, is that we are not, we want to have not arrays here, but we want to have like POJOs, Java POJOs, objects, classes, which can be some domain classes. So you can classify transaction, you can classify user, you can classify product, and the product itself will know how to convert itself to array, and it will be even more readable. And what's important it will be less error prone and more intuitive to use. So you will be doing machine learning using plain Java objects, not some low-level data structures. So I would like to mention that the entire JSR, the reference implementation, the main implementation on which we are testing these ideas and developing, is based on DeepNet's Community Edition. DeepNet is Java-based deep learning library and development tools provided by DeepNet. You have a link here, and take a look. There are also some interesting IDE-like tools which will support this kind of APIs and just provide out-of-the-box components which are based on these APIs. And here you have a link to get more information, and if you want to take a look at the source code and how it works, you have a link to GitHub. And I would like to add that it is a pure Java implementation of deep learning, so that's why it is very interesting. It was a kind of research to see what Java can do. It does not have GPU support, which does not make it suitable for large-scale problems, for millions of images or terabytes of data, but it can do medium and small-sized problems very well. And it supports the most important deep learning algorithms. So now I would like to hand it to Kevin, and he will show you how this API works in practice in his demo. Kevin?
Yes, thank you, Zoran. Gonna share my screen really quick. So welcome to the last part of the presentation. I'm gonna show you a demo that's involving Star Wars. So for this demo, as you can see here on the slide, I've got on the right the Millennium Falcon and the TIE Fighter on the left side. Those are very iconic aircrafts from Star Wars franchise, if you've seen it. Before I'm going to start with the demo, all the source code can be downloaded on our GitHub repository, which is all publicly available. So for this demo, the problem is that I'm going to tell the computer or the program to identify which aircraft is which one. So for example, on the right side, for me, it's obvious that's the Millennium Falcon, and on the left side, it's the TIE Fighter. But the computer doesn't know. So using our API and a really, really small data set, I was being able to accomplish the thing that I needed. And for this demo, we are going to be using the neural net image classifier, which was also shown at the slides from Zoran a few slides back. Let's get to the code really quick. So this is all the code that you need to train a model. So it's not much, it's probably like 10 to 12 lines of code, and that's all you need to train a model. So it's really simplistic once you've learned what all the parameters are and what you have to fill in. So, and the rest is all about preparing your data set for the model to train. So let's get to all the builder methods that we are using. So first we are creating the builder, and we're gonna set the input class to buffered image. So each implementation is really basically forced to implement an image classifier that's able to classify a buffered image. So so for a beginner like myself, I would just grab this piece of code, and I would certainly know that if I give a buffered image as input, that's going to succeed. So the next two parameters are the image height and image width. These values are used also for normalization of the input. And it basically really means that it's resizing the input image to these parameters. It's all defined also in pixels, so keep in mind for that. Which is also shown later in the network architecture, but I will get to that later. And the reason why I set this to 50 is that I've been experimenting with different kind of values. A few slides back, Soren showed you an example using MNIST, and it had input of 28, and also those are different. Those are rather smaller characters, and that would also mean that if you got smaller images, that it would take less time to train the model, because the bigger the image, the longer it takes for the machine learning algorithm to go through all the data that's within the image. But for this example, I find out that the accuracy was significantly higher than when I was using 28 or 128, and 128 was taking way too long for the small data set that I had, and I was just all about experimenting with it. So then we get to the labels file and the trainings file. So there's a really basic files with just text in it. I'm gonna show you right away what's in it. So on the left side, the left box, the blue box, is the labels file. It contains all the labels, all the different kind of classes that you have that needs to be trained within the model. So here I have the Millennium Falcon and the TIE Fighter. So those are only those two that they need. And on the right side, you have the trainings file, which is really the first segment of the line. It starts with the file name of the image that's used in the data set, and then separated by space. And then after that, you got the label that's assigned to that image. So the engine knows which image belongs to which label and which class, really. So those are only 5 of them. But in reality, I had like probably about 120 entries within the trainings file. So once we've got that set up, I was all about picking the network architecture. So I have no prior experience in machine learning or deep learning or AI in general before I joined this GSR. So what I did, like many other data scientists really much do, is they pick an existing model. So that's what I did as well. So on the right side is an image, is the network architecture visualized by DeepNet's IDE. And it shows you all the different kind of layers. And it always starts with an input layer and an output layer. And those are the only 2 things that I fine-tuned a bit to our current need of the demo. I'm going to show you also what I changed, but that's what I did. So this is the model, this is the network architecture that's used in the MNIST demo. And we're just going to reuse it. So the width and the height of the image of the input layer, so the first layer that's defined in JSON, I had to change that to 50. So also the value that I put into the builder. And then in the output layer, I set the width to 2. It was previously set as 10 because it had 10 different kind of classes in the MNIST demo. So I had to change that, which is equivalent to the amount of labels that you have. Then I want to export the model, because I want to use this trained model in the demo that I'm going to be using. So in the demo, I'm not going to train this model. It takes like about 50 to 51 seconds. It's obviously not that long, but just to reduce that time. But so it's going to export the model to your file, to your system file path. And then at last, you have the training parameters. So these are really, there's no really a golden value, I would say, for these training parameters. But I'm gonna show you why I picked those. So I was really experimenting with this. So I was putting it on 10 or 1 or 0.1 for the max error. I was really about experimenting with it. And this also means that if you put a very low value, it will take much more time to train a model, but it doesn't necessarily improve the accuracy. So that's all about experimenting. It took me a day to fine tune these values. So the max error, I will get to that later because I can also show you the output. That's going to be much easier to explain then. And then you have the max epochs. So the epochs are really iteration. So for each iteration, so after 100 iteration, it's going to stop training, and then it says that the trained model is complete. And the learning rate, yeah, it's really about how fast I'm going to allow this engine to train this model. This is also, there's no goal and value to it. Just experiment with it. Yeah, it's really about experimenting and see what the outcome is. Also, I really have a small data set, a really small data set. So about 60 to 50 images per class. So that's really small. I would say to try to aim much higher to hundreds or thousands images per class. That would definitely improve the accuracy. So yeah, at the end you build the image classifier, and then so we get to this part. So this is the output that DeepNet is showing because I'm using DeepNet for the demo. Here says is that training the neural network, and then the end is complete. And here you have the different iterations. So I show you the first two and the last two. You can also see that that the epochs, the iteration, they stop at 24. That's really because it's not the iterations that's stopping the training or saying that the training is complete. It's all about the train error. So if you look at the first two iterations, it has a relatively higher train error, and each iteration it brings down that number. It's not linear, so it has really a steep curve at the end. Or so if you look at iteration 23 and 24, here it's still above the limit that I'm giving the engine, and then at iteration 24, it's below the value that I had put into. So that's the 0.03, and it's below that value. So that's a signal to stop the training, and then it took about 51 seconds to train a model. So then once we completed the training, we want to use the model. So if you have a trained model, the API is not much any different. The only thing that is different is that you don't have all those training parameters. You don't have to define the labels file, training file, and the network architecture. And the export model is replaced with import model. So you're just gonna change that, and it just imports that model, and you're good to go. You are good to go to use that classifier and classify the images that you want. So that brings us actually to the real demo. I'm gonna switch over to my console, and I'm gonna spin up the application. So for this demo, I'm using JavaFX to visualize the usage of a trained model. So here I have a really small application, GUI, that's able to open a trained model, open an image, and then classify that image. And after classifying the image, it will pop up with the accuracy of the results. So let's start by opening the model. So here I have the project folder that I mentioned about, and then I define DeepNet as folder of output with trained model.deepnet.dnet as a file name. So I'm just going to open that. In the background, it could be spewing out some noise. So now I've loaded the model. I want to open an image. So also in the repository, you've got test images which are not used, which are very much different images than used for training. So these images are picked from Google, and the other ones are from another GitHub repository, also from another movie, different from the images that I'm using for testing. So here I have the Millennium Falcon folder, and I've got 3 images. So just gonna see what happens. So here we go. So here we have the image, and we're gonna press on classify. And as you can see, once I clicked on classify, the results came pretty much instantly. So this for this image, the model is gonna say that the trained model is gonna say that it has 87% accuracy, which is really nice. Just let's use other images. Also note that this image is really small in size and has a real small resolution to it. So that's 27 by 27 resolution, and it's only 21 kilobytes. There's another image, the third image that is much bigger. So it takes also more time to classify to see what it is. So it takes like about 1 to 2 seconds, but it's showing as result 90% accuracy, which is really even better than the previous image. And then the last image for the Millennium Falcon. So this one has some noise within the image and at the corners. I believe that's the issue. That's also the reason why the accuracy is much lower. So it's 66. But again, this is really classification is really fast. So now let's try for a TIE fighter. Here we have a TIE fighter. Also, the image is really small. It's just only 6 kilobytes. And it's pretty much a really decent image. And it's gonna say 77%. That's a TIE fighter. So that's now we know that the model is really doing its job. It's really trained properly. Also for this use case, the accuracy that those are shown for us it's okay. In certain use cases, I can imagine that you don't want to be, for example, for this image, it shows 54% that's accurate. That's a TIE fighter. And in some use cases, you don't want that low of an accuracy. So you should either be, you should both be fine-tuning the architecture, the network architecture, but also fine-tuning the data set that you have. And the reason why really is that the image is really fake. So it's fading at the bottom a bit. So it's only showing half of the image really of the TIE fighter. So that's also a factor of that's why the accuracy is lower. And then a very clear image, which is showing proper results of 67% accuracy. So that's so that was the actual demo. Let's get back to you, Frank. Frank?
Yeah, Rodrigo.
Okay. I thought that you had something to add, Frank. If not, I think we can jump to our Q&A.
Great.
All right. Jean, please.
Awesome. Frank has done an excellent job answering questions, so he's not going to be surprised when I ask the same questions. But it is useful to have them asked in the YouTube video for people who are listening and also for people who are watching later. So Frank, can you tell us about the JavaScript doomsday scenario and what it means to you, and also why WebAssembly doesn't solve it?
That's a very good question. So what I meant by the doomsday scenario, it wasn't a dig against JavaScript, although with a few beers I can be persuaded. It meant that we had this phenomenal invention called the web, and we only had one language for all of the world's creativity to use the web. Now, we got some wonderful things out of JavaScript and the web, but there are other languages and there are other ways of expressing yourself. So the way I look at it, having only one way of doing things is very, very bad for the world and for humanity. So that's what I meant by doomsday scenario. And why WebAssembly doesn't solve that. I've had a recent discussion with this with Brian Sletton. So with WebAssembly, my hope was that it would allow people to use other languages other than JavaScript. Every WebAssembly consultant expert I've talked to said, like, it's not quite that. Yes, you can compile like potentially a C program to work in the browser, but you still have to deal with JavaScript in some fashion. So it's not a complete replacement. Although Brian has told me that that's not completely true. So I'm trying to get the scoop on that. So stay tuned.
Okay. Our next question is JSR 381 a wrapper or a level of abstraction friendly to a Java programmer, and actual number crunching happens in native languages, libraries, or something else?
Zoran, maybe you want to answer that one?
Well, yes. It is an abstraction layer. It is not a wrapper. One of the implementation, for example, DJL, it is a wrapper for MXNet and for TensorFlow and PyTorch. But the JSR 381 is more like abstraction on top of implementations that can be wrappers. And yes, it is wrapper on top of native libraries. But the reference implementation is pure Java implementation. DeepNet is pure Java implementation, and that's what makes it easier to integrate and play with other Java applications very easily.
And I should add that since it's a JSR, it's a standard API, which is very important.
Yes, it is standard API. Exactly. Thank you.
Two more questions about the JSR. One of them is, where's the best place to learn more about it and the work being done? And the other is, do you have any predictions what version of Java the JSR will make it into?
So go ahead. You can answer the Java one. I'll see if I have that slide with the links on it.
Yeah, this getting started document. It is the best place. And GitHub, Frank will give you the links now. They are available in presentation, which I guess it will be available. GitHub includes getting started documents, and there is a mailing list on which you can ask questions, and then if you would like to get more information.
Actually, that's a good suggestion. I will put the links in the body down below the video, so you'll see it right away, and as opposed to showing the slide right now. That'll be much better.
That's great. If you're pasting stuff, can you also paste the link to the GitHub repo that was shown today?
Definitely will.
I was going to ask that later, but I don't want to make you copy and paste twice. That's just extra work. Does the JSR have anything in it about GPU support and/or specs?
Well, GPU support is a separate thing, but we are talking about that. We are looking ways to make that happen. And ongoing is discussion how to support ND arrays. And through that will also come GPU. So at the moment, the discussion is mainly being carried on TensorFlow Java SIG mailing list. That's where it started. So TensorFlow Java implementation, also we have people from Oracle, people from together and provide some specification for ND arrays. And that will also include some kind of integration and support for GPUs.
Okay. We're down to our last two questions. So if you have more questions, now is an excellent time to put them in the YouTube chat. Our possibly second to last question is about the image training set. What happens if you put multiple TIE fighters in one image and try to classify, was it part of the training set?
Well, it should be able to recognize them, regardless. Classification says, is there a TIE fighter on the image? So, and the convolutional networks should make it possible to detect the TIE fighter on the different locations in the image. But yeah, yes, it depends of the sample. So you have to have good sample in data set. There are no guarantees. It's just a trial and error. That's one of the main issues with the machine learning and deep learning today. That it involves a lot of experimentation in order to make it work.
Okay.
And just let me just add one quick thing. Just so for people that are new to machine learning, there's two phases to solving a problem. There's the training. This is made obvious by Kevin's demo. There's the training aspect where the actual learning occurs, and then there's the prediction or inference phase. So for those that are new, there's the training, and then you do the prediction or inference. Just to be clear.
Okay, and our possibly last question is, where do you factor in whether the images are grayscale or not, or does it matter?
Sorry, can you repeat just to make sure that I get it?
Where do you factor in whether the images are grayscale or not, or does it not matter?
It doesn't matter. It doesn't matter. If you want to learn shape regardless of color, you have to just provide a good sample of colored image and grayscale images. Or you can grayscale all the images. If you want to make sure the different color of some object, let's say car or differently dressed man makes a difference, then you just grayscale them all and then train. That's a part of pre-processing data, which is one also important step. And even there is a step called data set augmentation, in which you provide different variations of the original data by grayscaling, translating, rotating, zooming, and so on.
Okay. And my last question, because we got to end with a fun one, is ML going to take over the world?
Of course. Thanks to JSharp 381, yes.
Good to know.
Right now. This is the start.
With that, I turn it over to Rodrigo.
All right, thank you, June. I have one final question to you, Kevin. You were testing. You were saying you're using really small images, right? If you use larger images, would that impact the time to give the result?
Yeah, definitely, because it takes it has to go through all the data. It also affects the training. So, for example, if you have large images in your data set, or the network architecture is large, it will definitely have impact negatively on the training time.
Okay,
so I would recommend to start with smaller images, be consistent in the images. Also, the background of the images are really important.
okay.
Yeah, just all about experimenting, really.
All right, thank you. All right, in the name of the NY Java SIG, I would like to thank you, Kevin. Thank you, Zoran. Thank you, Frank, for this. I would like to let you know that our next event is next week, June 24th. Special time, it will be at noon. If you want to know more about it, what we're going to be talking about it, follow us here, NY Java SIG on Twitter. You're going to be knowing firsthand. All right. I would like to thank everyone that joined participation here on YouTube, asking questions. Thank you very much. I think that's all we have for today. Thank you. Enjoy the rest of your day. Have a good one.
Thank you.